Lights only work if they can get power and data. The cable tools we've added to Vectorworks Spotlight help production electricians not only plan out how much cable they need on site, but plan where and how it will get to the lights. The cable tools are a collection of 4 tools and several menu commands. Let's start with a basic understanding of how the tools work in a simple file. In this file, we have a 100 amp source, which we will run cable from to our dimmer rack. First, I want to draw a feeder cable from the source to the dimmer rack. Select the feeder cable tool from the Spotlight toolset. The cable tools all use the same polyline drawing modes, which allow you to draw in any direction or shape. Click to start drawing the feeder cable. Continue clicking until you want to stop the feeder cable. Double-click to end. You'll see some information displayed on the feeder cable, which will also help plan how much cable is needed. In my example, you can see that I need a 75-foot cable. The Calculate Parts checkbox in the Object Info palette will calculate how long the cable needs to be. This is based on the available inventory lengths in the document. You can see the stock lengths in the Object Info palette. To modify the stock lengths, go to Spotlight, Cables, Cable Preferences. The feeder cable lengths available to you can be entered here and separated by a /. Based on my stock lengths, I can see that I need a 75-foot cable and I will have 22 feet left over. I can then pick up the feeder cable type in the Object Info palette. In this example, we'll use 5-wire multi-cable. There are also some ID fields in the Object Info palette that can be displayed on the cable. The cable run ID will show at the beginning of the cable. I'll enter back of house here. The rack ID will specify what rack it goes into, like dimmer 1. You can also enter a box, port, or loom ID if you're using a splitter box, have multiple outputs, or if the feeder cable is being bundled with other cables. The tape color code can help you quickly identify what cables go where on site based on the color. We can choose what type of connector or adapter we want to use as well. We can enter the weight per foot of the cable, which will calculate the total weight. The parts section will auto-build up to 9 parts as needed. If you increase the total length of the cable, it will add a new part based on the sizes in your inventory. You can also account for the vertical travel of the cable by entering the vertical distance for each part. The max amperage can be entered depending on the max number of amps the cable can handle. You can also choose the voltage in the dropdown or enter in another voltage value. Depending on the voltage, the type, the length, and other info, you can see how much voltage is dropped and what percentage. In this case, voltage delivered is 117 volts. You can enter an inventory ID or user-defined fields for reporting the cable. Mark connections will show any connections at the start and end of the cable. You can lock the position of the label on the cable and choose what info is displayed. The Classes button allows you to control these labels' classes. Now that we have the feeder plugged into the rack, we need to get power to our lights on the stage. Click on the Jumper Cable tool and click to start drawing the cable. In this example, we will draw it down and to the first fixture on the left. This is a moving light, so let's change the connector to L6-20. Now, I want to jump the power to the device on the right. With the Jumper Cable tool selected, click on the device on the left. Double-click on the device on the right to end the cable. This is passing power, so let's change the connector to Power Con for this jumper cable. We can follow the same procedure with the Data Cable tool. We need to run power down to the fixtures in the drawing. We'll do this with the Multi-Cable tool. The drawing method for multi-cable is the same as the feeder and data cables. Click once to start drawing the multi-cable. In this example, we'll draw it from the rack down to the fixtures on the truss. Double-click to stop drawing. The truss here is 18 feet high, so let's enter a vertical distance in the Object Info palette and make sure we have some extra just in case. This will cause the multi-cable to recalculate the parts, and you'll be prompted with this dialog telling you the part values will be erased. Click OK to close the dialog and recalculate. Now I need another cable, so I will duplicate the existing cable. I can use the Reshape tool to move the endpoint of the new cable to where it needs to be. I now need a data cable for the moving light, so I can draw a new cable using the Data Cable tool, or I can use the Convert to Cable menu. If I select the multi-cable and go to Spotlight, Cables, Convert to Cable, I can convert the multi-cable to a data cable. I can also copy some of the parameter values from the existing cable. In this case, I'll choose to copy part lengths. If you need to select all of a certain type of cable, you can do this easily through the Select Cables command. Go to Spotlight, Cables, Select Cables. In the Select dropdown, I'm going to choose multi-cables. You can select them according to various criteria, but in this case, I want to select them all. Now that I have both multi-cables selected, I can give them IDs. Go to the Cables menu and choose Assign Multi-Cable Run ID. In the Assign Multi-Cable Run ID dialog, you can assign a fixed ID value that will be the same for every fixture that is assigned an ID. We can also increment the ID numerically or by an alpha character. Click OK to close the dialog. The IDs have been assigned in the order that the cables were drawn. To start wiring these fixtures, I first need to set my multi-cable jumper preferences. In the Preferences dialog, we can determine how the multi-cables get the jumper cables from the fan out to the light fixture. If I have an 11-foot breakout and my light is 18 feet away, I wouldn't want a 25-foot cable from the fan out, since that would leave me with a lot of extra cable. So what we can do is subtract the breakout length from the jumper length. The breakout type, adapters, and length can all be specified in the object info palette for the multi-cable object. Cable orthogonally will allow you to choose the direction of the cable instead of just the shortest path. This is useful for truss, but for something like a stage deck, you'll likely uncheck this, as you may want the straightest path. Ganging device location will be used if we have multiple objects on a single circuit. In this example, we won't use this. Now that we have the preferences set up the way we want, we can assign multi-cable circuits. I can start numbering at 1 and click OK. The first thing we'll see is a message asking for you to click on the first fixture. This will make it A1. Click on the next fixture, which will be A2. Continue clicking on the fixtures in the order you want. Click in a blank area of the document to end the command. You can also control what information is shown in the breakout label. Go to Spotlight, Cables, Place Breakout Label. Here, you can choose what layer to place the breakout cable on and what label type to use. You can click and drag the breakout label to where you want it. The leader will always point to the head. You can change the breakout type in the Object Info palette. Next, I want to jump power and data between my moving lights. To do this, I can create a jumper cable chain. Let's choose Make Jumper Cable Chain. I can now copy the information from one device to another, like the circuit name and number. Click OK to close this dialog. Now, I'll click on the moving lights in the drawing, and then click on a blank area to end the command. I can now see the different jumper cable objects drawn from one device to another. I can do the same for the data. Click on Make Data Cable Chain in the Cables menu. I don't really have any options for this, since it will just pass the data and not share anything. So I'll now click on each moving light, and then click in a blank area to end the command and create the data cables. If you want to control the offset of the jumper or data cable from where you clicked, or the spacing from the cable to the device, you can set these values in the Cable Preferences dialog. Once you have your cable drawn, you can find specific distances on the cable if you need to. Get Distance Start to Click will show you the distance of the selected point from the start of the cable. For instance, this would be useful if you knew the door needed to close. You can find the distance at this point on the cable. In this example, with an 8-foot vertical distance, the point is about 47 feet. I know if I have a 50-foot cable, I can break the cable here and then be able to close the door. You can mark a specific distance on the cable, enter a value, and it will display a marker at that point on the cable. Finally, you can create a worksheet for the cables and choose what information is shown.